The basic idea of this is we are taking the knowledge of exponents and using it algebraically. We're taking what we know about exponents already and we're using it algebraically. So, let's look at this problem. X squared times y to the fourth times z to the third times y squared times x to the fourth. Now, if I'm looking at that, that's a true algebra problem. It's got variables, which are unknown, and multiple of them, right? Like, it's difficult. There's no equal sign, so I'm not trying to find an answer. I just want to find an easier way to write this. So, here's how we're going to say it. When in doubt, write it out. If you don't understand, we're going to actually talk about, we're going to discover a rule. But when you're in doubt, you're going to write it all out. So, if I look, x squared is really x times x. And y to the fourth is really y times y times y times y. And z to the third is really z times z. Oh, third, z. 3 of them. And y squared is really y times y. And x to the fourth is x times x times x times x. Right? If I wrote it all the way up saying no exponents at all, can you now tell me how many x's are in this problem total?
6.
I've got 1, 2, 3, 4, 5, 6. X to the 6th. Can you tell me how many total y's are in this problem? 1, 2, 3, 4, 5, 6. And can you tell me how many z's are in this problem? 1, 2, 3. So if you can't see a pattern, you don't understand, if you write it all the way out, if you expand it, you make it really big, then you can just count how many there are and we're good. However, there's a rule. There's a simple rule to follow. And if you memorize the rule, you don't have to do all of this. Is doing this all okay? Yes. So here's the rule. When powers have the same base, when powers have the same base, which one's the base? The big number, the bottom number. In this expression, x, y, z, y, x, those are the bases. When powers have the same base, what do you think you do? You add what? The exponents. When powers have the same base, all you do is add the exponents. Because look, x squared and x to the fourth, 2 plus 4 is 6. And y to the fourth and y squared, those are the same base. They're both y. And 4 plus 2 is 6. And then z to the third is all by itself, so it's z to the third. It doesn't get added to anything. When powers have the same base, all you do is add the exponents. When in doubt, write it all the way out. If you don't see, write it out. Yes, it takes a lot of space, but you're going to get it right. Now, here's a trick. What if this is your problem? Declan, turn around, please. What if your problem is negative 2x to the third times 5x squared? What if your equation, your expression, your problem is negative 2x to the third times 5x to the second, or 5x squared? Well, let's write it all out. Let's do that in case we don't get the rule. What does negative 2x to the third look like? Audrey? Negative 2 times x times x times x. 3 x's. What does 5x squared look like? 5x times x. When in doubt, write it out. If I write it all the way out, okay, now I can find my answer. But here's the trick. I count 1, 2, 3, 4, 5, x to the fifth. I counted those. But what do you think I should do with those coefficients? I should combine like terms. And they're like terms, right? Negative 2 times 5. So the rule is, when in doubt, write it out and do the math, right? Figure it out. Could you, if the powers have the same base, could you have added the exponents? What's the base here? X, not the negative 2, because the exponent, the 3, only touches the x. What's the base here? X. Don't say 5, because the exponent of 2 only touches the x. Are the bases the same? If the bases are the same, add the exponents. 3 plus 2 is 5. So if the bases are the same, add the exponents. That's our rule. However, if the powers have coefficients, what's a coefficient? A number in front of what? A number in front of a variable. If the powers have coefficients, numbers in front of the variable, what do you do with those coefficients? Yeah, we multiply them. We combine them. And the reason we multiply them is because this is a multiplication problem. Since it's a multiplication problem, can you multiply numbers? Yes. So when the powers have the same base, add the exponents. If the powers have coefficients, multiply them. We'll finish it. All right, let's try another problem. What if I have m to the third to the fourth? What if my problem says m to the third to the fourth? Well, what's our rule?
Write it out.
When in doubt, write it out, correct? So what does m to the third to the fourth mean? M to the third, and how many times are we going to write m to the third? No. 4 times. So let's do it. M to the third times m to the third times m to the third times m to the third. Is that what it means?
Yeah.
Yeah. M to the third to the fourth means I'm going to have 4 of these guys. 1, 2, 3, 4. Right? Okay, so let's keep going. If I look at this problem, do you know anything about this problem, Audrey, that we already learned? Is there anything we know about this problem already? Is there any rule that we've already learned that you could do to this problem, Colin?
They have the same base, so add the exponent.
They have the same base, m, and m. So I add the exponents. 3 plus 3 is 6, plus 3, plus 3. M to the 12th. Hold on. Before you start telling me shortcuts, let's do another one. Two x to the third. I'm going to make this to the 6th. Let's make it really hard. 2x to the third to the 6th. Hold on. When in doubt, write it out. 2x to the third, 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 2x to the third. Okay. So some of you have said, but Mrs. Long, I see something over here. I see a shortcut. And I'm saying, perfect, we'll get there. What happens over here? Let's think of our rules that we already learned. When the bases are the same, add the exponents. So ladies and gentlemen, what's the base in 2x to the third? X. Don't say 2, because the 3 only touches the x. So x to the 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18. However, we're not done because that is not my answer. The first rule we learned said when powers have the same base, add the exponents. We did that. The second rule we said if the powers have coefficients, numbers in front of a variable, multiply them. 2 times 2 is times 2. 8 times 2 times 2 times 2. So, is there a rule if the power has an exponent? Right? Meaning this. If the power has its own exponent, right? If the power has its own exponent. Audrey, what was the rule you discovered? Yeah. If the power has an exponent, right? I'm even going to put in there again, if exponents touch, right? 2 exponents are touching. Multiply the exponents. So in this problem, instead of x squared to the 4th, you'd do 2 times 4, so you'd get x to the 8th. In this problem, we wrote it out, but you could have done 3 times 4 and gotten 12. In this problem, you could have done 3 times 6 to get 18. If you don't understand it, can you still write it out? Yes. Here's the second part. If the power has an exponent and a coefficient, like in this problem right here, 2x to the 3rd to the 6th. It has its own exponent of 6, but it also has a coefficient of 2. If the power has an exponent and a coefficient, the exponent belongs to both the variable and the number. Basically, it gets distributed. Anything outside a set of parentheses, remember, gets distributed inside a set of parentheses. Remember the distributive property? If the power has an exponent, so an exponent touches an exponent, and there's a coefficient, that exponent belongs to both the variable and the number. Guys, remember, anything outside parentheses gets multiplied inside. So that 6 belongs to the x to the 3rd, and that 6 exponent belongs to the 2. 2 to the 6th power is 64. 1, 2, 3, 4, 5, 6. 2 times itself 6 times is 64. And it belongs in here, you multiply. Do not confuse these two rules. You add the exponents when it's a multiplication problem. You multiply the exponents when it's an exponent touching an exponent. Ladies and gentlemen, 100% of the time, when in doubt, write it out. It works every single time. You don't get confused because you write it out and you can visually see it.